Okay, let's continue. The following part is the difference, okay, between the values of the two situations, let's say, instead of two populations. Because we are going to have what? The same sample size for the two populations, population 1 and population 2, okay? But these are really probably the same subjects. We are going to change a methodology, a treatment, or something that really is going to say if there is a significant difference between these two situations. When we do use this, let's say that I have two possible tastes for my product. I use one population and taste this and then taste the other, and we are going to compare if really there is a significant difference between the two flavors, let's say. Or if we use a process for a production process in order to increase the effectiveness of my production process, or increase the number of units per hour that I produce, or whatever it is, that we are dealing with the difference between the two populations. So there are what is called the matches samples, and we are dealing with the differences. Okay, and d bar is equal to the summation of the d's divided by n, like the whatever, and the standard deviation of that sample is equal to the summation of the d's minus d bar squared divided by the square root of n minus 1. Okay? The square, everything is the square root. Okay, divided by n minus 1, everything is square root, not only the denominator. Okay? And we have the test statistics is a d bar minus the mu sub d, that the one that we are going to compare with in the hypothesis testing, divided by what? S sub d divided by the square root of n. That's the test statistic that we are going to use. We are going to use the test distribution, the t distribution, and how many degrees of freedom? N minus 1. So it's pretty easy, the degrees of freedom over here, because we do have a sample of n in each side, so it's n minus 1 the degrees of freedom. So it's pretty easy and pretty simple. And that's it. And for the confidence interval, we have the d bar plus or minus the t of alpha divided by 2 times the s sub d over square root of n. That's for the confidence intervals, that's for hypothesis testing. That's it. The rest of the things are exactly the same. Okay? So, let's do a problem. I guess. If you don't do a problem, then you might not get this. Let's do problem number 20, so you can compute everything, so you have the samples on each one of the treatments. Let's do problem 20, okay? And we do have the 7 elements, okay, or 7 samples, and we have the population number 1 and population number 2, and we are going to have this situation over here. In the first treatment, I have my 7 values, and those are 11, 7, 9, 12, 13, 15, 15. Okay? And and the population 8867, 10, 15, 14. Okay, first we need to compute the differences between the two populations that is really what we are interested in. 11 minus 8 is 3. 7 minus 8, negative 1. 9 minus 6 is 3, is 5, 3, 0, and 1. Okay, that's the difference. Now, what is d bar? D bar is equal to the summation of the d's divided by n, and that is equal to 14 divided by 7. So my d bar is equal to 2. Okay, d bar is equal to 2. Now, in order to compute the standard deviation of the difference, we need what? The formula. Standard deviation is the square root of the summation of each one of the d's minus d bar squared divided by n minus 1. Okay, so let's compute that. We already have the d's, and we do have the d bar that is equal to 2, so what we're going to do is to have this d minus d bar. So it's this d minus 2, that is my d bar. Okay, 2, this is 1, minus 1, minus 2 is minus 3, 3 minus 2 is 1, 5 minus 2 is 3, 3 minus 1 is 1, 0 minus 2 is negative 2, 1 minus 1 is negative 1. Okay? So 3 minus 1 is 1, minus 1 minus 2 is minus 3, 3 minus 1, 1, 5 minus 2 is 3, 3 minus 2 is 1, 0 minus 2 is negative 2, and 1 minus 2 is negative 1. Okay, now I have this. I have to square it. Okay? Square b minus d bar squared. What I'm going to do is just square this one. This is 1, 9, 1, 9, 1, 4, and 1. I just square this column. 1 squared is 1. 3, minus 3 squared is positive 9. 1 squared is 1. 2 minus 2 squared is 4, and so on. Then I need to do what? The summation of this column. What is the summation of this column? Is 10, 20, 25, 26. Okay? And so that's it. So this is equal to this summation over here, that is 26 divided by n minus 1. We have 7, so it's n minus 1 is 6, the square root, and that is equal to 26 divided by 6, the square root, 2.08. That is the standard deviation of my differences in the samples. Okay. Okay, compute the difference, compute the VAR, compute the standard deviation. What is the point estimate of the difference in the two populations? It's d VAR, right? That is d VAR is equal to 2. That is the point estimate on the differences. And provide the 95% confidence interval. Okay, 95% confidence interval is equal to 2 plus or minus t of alpha divided by 2 times what? The standard deviation of the difference, 2.08 divided by the square root of n, and n is equal to 7. So what is t alpha divided by 2? Okay, go to the table, go to the t table. How many degrees of freedom? N minus 1. So in this case, n is 7, so we're going to use 6. And t of alpha divided by 2, and alpha is 0.05. So it's 0.025, 2.447. So t of alpha divided by 2 is 2.447. So the confidence interval is what? 7 square root. times 2.447. So it's 2, the confidence is 2 plus or minus 1.92. This is my 95% confidence level, and that's it. That's it. Now, let's assume that for this problem, we have, this is the confidence interval. Let's assume this is not in your problem, but let's assume that we have all this information already, and we need to test the hypothesis testing about what? That there are differences or not differences in these situations. That my hypothesis is that the mu of the difference is equal to 0, and the alternative is that the mu of the difference not equal to 0. In this case, we do have a two-tailed test, okay? And if we are dealing with 95% confidence level, we are dealing with 0.025 here and 0.025 here, okay? And the critical values are, remember, n-1 degrees of freedom, 6, and 0.025 is 2.447. Negative and positive. Okay, now what is the test value over here? Is what? D bar minus, in this case 0, divided by what? The standard deviation of the difference over the square root of n, and that is equal to 2 divided by 2.08 over the square root of 7, and that is equal to what? .54. This 2.54 is right in here and is in the rejection zone. So if it's in the rejection zone, we reject the null hypothesis and we conclude that the difference is not equal to 0. So the two populations are not equal statistically. There are differences between the two populations or treatments, if you will. That's it.